Good morning, ladies and gentlemen. My name is Beata Bohentin, and it's my great pleasure to welcome you at our virtual open days of the Faculty of Applied Physics and Mathematics. Our presentation will be divided into 4 parts. In the beginning, Dr. Justyna Szostak will make a short introduction to the studies of physics at our faculty, but remember that we are still open to answering your questions. Please ask them on the chat close to the video stream on the YouTube channel, or you can also ask the questions to our students who are waiting for you on the MS Teams platform. Thank you.
Good morning, good afternoon, depending on where you are. As you already know, my name is Justyna Szostak, and I'm the head of the Rector's Internationalization Committee, and on behalf of the authorities of our university, Gdańsk University of Technology, Gdańsk Tech, and the authorities of our faculty, the Faculty of Applied Physics and Mathematics, I will take you on a short trip around the university and our faculty. We are localized exactly in the center of Europe, in Gdańsk, in a beautiful city, and as you probably know, it is very easy to reach us via all the means of transport. So disregarding where you are, you will get to our location very easily. How does our university look like? We have 77 hectares of the campus area. We have both modern buildings, modern facilities, research centers, as well as really charming, majestic buildings from the 20th century. We have great lecture halls, highly specialized laboratories, and really beautiful places to rest. We provide the highest quality of education and research, and therefore we are recognized in most of the important international and national rankings, including one of the most important ones, which is the Shanghai ranking and the QS World University ranking, but we also appear in the Times Higher Education ranking and the U Multi-Rank ranking, so you can search for us practically everywhere and get additional information about our university. It is really important that, that we are highly ranked also in the Polish national rankings, including one of the most important ones for students, which is the Perspektywy ranking, which checks the students' perspective on the university. And according to that ranking, we are usually third or fourth among technical universities, and third most frequently chosen by candidates, also by international candidates. What is really important, we have been ranked the 2nd place in a very prestigious competition organized by the Polish Ministry of Higher Education, right now called the Ministry of Education and Science Poland. We are the best among technical research universities in Poland. The quality of education and research that we run is also confirmed by many accreditations that we called and the certificates, including the most important ones for you as candidates, as future students, which is the ECTS label and HR Excellence in Research. We are maybe not that much international university, but we try to increase the number of international students at Gdańsk Tech. Right now we have almost 1,000 students from all around the world, and the number of all of the students at the university is about 15,000, so it's about 5 to 7% of all of the students. Where our international students come from? They mainly come from India, Belarus, Ukraine, China, but also from Spain, France, Portugal, Germany, and many, many other countries. Our university has more than 720 international agreements, and these are the agreements not only for studies, but also for research and other types of collaboration. We hold over 600 Erasmus Plus agreements. That is very important to you as future students, because it allows you to take part in the international mobility for studies, traineeships, and other forms of mobility that I will discuss in detail in a few minutes. We also have over 30 double-degree prestigious agreements that allow you to be awarded 2 diplomas after graduation from one program of study. What else to be told about our university? We have a long tradition, so it's more than 100 years. We have 8 faculties and 13 leading disciplines, including the ones that we run at our faculty, which is physics, mathematics, and material science. Nanotechnology belongs to the family of material sciences. We have, as I mentioned, over 15,000 students, 37 fields of study, and 2 doctoral schools. As I mentioned, we have 8 faculties, and one of those is our faculty, the Faculty of Applied Physics and Mathematics, that I will show you right now. Our faculty consists of 3 institutes. We have the Institute of Physics and Computer Science, the Institute of Applied Mathematics, and the Institute of Nanotechnology and Materials Engineering. What are the research areas? We focus on applied mathematics, applied physics, medical physics, nanotechnology, materials engineering, and applied informatics. We run a lot of national and international projects. Right now we have 8 international research projects and 22 national scientific projects. We are sponsored by the European Commission, National Natural Science Foundation of China, Polish National Agency for Academic Exchange, National Science Center Poland, and Ministry of Science and Higher Education Poland. So as you see, we have a lot of sources of the financing of our research and education as well. What is the education that we provide? We run undergraduate, graduate, and doctoral studies in all research areas. That is financial mathematics, computer graphics, renewable energy sources, computer modeling, applied physics, biomedical engineering, nanostructures, and functional materials. We hold 6 double-degree international master's programs agreements and 65 staff and student exchange agreements within the Erasmus Plus program. But this is not the end about the international aspect of our faculty, and I will tell you a bit more later on. What is the educational offer of our faculty? We have a 7-semester undergraduate studies, and when you graduate from these programs, you become an engineer, in Polish inżynier. We offer you technical physics that is divided into 3 branches, which is applied physics, engineering of renewable energy resources, applied informatics. Then we have the nanotechnology, which is divided into 2, nanomaterials in engineering, medicine and cosmetology, nanomaterials and functional nanostructures. When it comes to materials engineering and the undergraduate programs, we have advanced engineering of functional materials. And the last program, that is a 7-semester program, is biomedical engineering. This is the interfaculty program organized in collaboration with 2 other faculties of our university. And here we have the specialization in medical physics. There is one more undergraduate program, which is a 6-semester program, and the graduates of that program become bachelors of mathematics. And this is financial mathematics or applied mathematics. When it comes to graduate programs, most of these programs are 3-semester postgraduate studies in technical physics, nanotechnology, and materials engineering, as well as biomedical engineering, which is again the interfaculty program, while we also offer 2 4-semester postgraduate programs in mathematics and what's most important for you, nanotechnology. Why is it most important for you? It's because this field of study is run in English, and the branch that we have here is the Nanostructures and Computer Simulations in Material Science. But we have also additional branches that are related to double-degree studies that I will also introduce to you a bit later on. When it comes to PhD studies, all of our programs are run in English, and we have doctoral studies in physical sciences, mathematics, and material science. and the PhD programs are run within the doctoral school. We have 2 doctoral schools. One of them is the Research and Development Doctoral School. Of course, you need a good place to study, to focus, and then we offer you the largest and the oldest, but also one of the most modern libraries in the Pomerania region where we are. We have 8 branches, so there is a separate branch of the library at every faculty. We have more than 400 reading room places, over 100 computers that you can use anytime. We have 500,000 printed collections and 13,000 active users of the virtual library system annually. We are investing to make our university more and more modern every year. As you see, these are the 3 biggest investments. We have the Laboratory of Innovative Power Technologies and Integration of Renewable Energy Sources. We have a supercomputer center that is developed right now, and the Eco Innovation Center of our university. But you have to remember that studying is not only about learning. So studying is also living and enjoying your life. Therefore, we try to organize a lot of extra activities of the university. It's called the 3rd mission of the university. So we have programs like the Open University, University for Many Generations, Baltic Science Festival, where we organize a lot of concerts, meetings, also scientific meetings for the society and the neighborhood. As I mentioned, studying is also about living, and we can offer you modern sports facilities, and you can use those facilities freely without any fee. We have 2 swimming pools, sauna, soccer fields, sports halls, tennis courts, aerobics room, gym, indoor rowing tanks, judo hall, climbing wall, and much, much more. And apart from that, you have to remember that Tri-City is a very beautiful region, and you can mingle with the nature after you finish your lectures. Thank you very much. If you have any questions, feel free to ask.
Interesting presentation of the studies at our university and the Faculty of Applied Physics and Mathematics. Now I'd like to introduce Professor Agnieszka Witkowska, who will tell you a little bit about this, about studying nanostructure and computer simulation in material science. This is a field of study which is fully realized in English at our faculty, so feel invited to listen. Agnieszka, the floor is yours.
Okay, hello everyone. It's my pleasure to present you our master study program in nanotechnology. This is a program which is implemented in international community offered by our Department of Applied Physics and Mathematics. And the name of this program is Nanostructures and Computer Simulations in Material Science, as my colleague Justyna said before in the first part of this open hour. Okay, so if you want to study an advanced and interdisciplinary field of study, if you like to study in international community, and finally, if you would like to study in Poland, so Gdańsk University of Technology opens the door for you. And I can say that you must join us, and you must join our study program in nanotechnology, because this program is just for you, exactly for you. Okay, so Nanostructures and Computer Simulations in Material Science, this master study program is a 4th-semester program, as you just know. So implementing this program by 4th semester, you must collect at least 120 ACTS credits points. As you just know, this is a program which is entire in the sense of lecture, exercises, seminars, projects, and laboratories conducted in English. And is opened for mainly international candidates, but also for Polish candidates too. So in this sense, this is really program dedicated to international community and is realized in a multicultural environment, I can say. Candidates for this program should hold a bachelor's degree or engineering degree in related to nanotechnology fields. So, for example, in physics, nanotechnology, obviously mathematics, material science, but also mechanical engineering, electrical engineering, and let's say informatics too can be accepted as a related field of study. To facilitate your admission, we offer you online admission procedure, and admission procedure starts for foreign students in May, so really soon. Quite 1 month, we start with admission for foreign students, foreign candidates. For Polish students, admission start in July. If you would like to know more details about admission procedure, about deadlines, documents and requirements, linguistic requirements, please follow this link, this website, when you can find all up-to-date information as regards admission procedure. Classes start in fall semester, in winter semester, so in general this is close to the October 1st. And after first semester, this fall semester, we have exam session and in February, and from the end of February we start the next summer semester, and each semester lasts 15 weeks. Okay. The program ends with master thesis project realization, and to be clear, in fact, quite whole last semester, fourth semester, is dedicated to this master thesis project. And we finish the program with diploma examination, and if you pass this examination, you will be awarded with a Master of Science in Engineering, obviously in nanotechnology degree, what mean in Polish Magister Inżynier. And after awarding this Master of Science in Engineering, you can apply for our doctoral PhD schools, which we have two, as you can hear for moment ago about this possibility, this school. So you can apply also for PhD for other level of education. Okay, all lectures, exercises, seminars, projects, laboratories are conducted by professors and researchers of Institute of Nanotechnology and Material Engineering and are performed in building of Nanotechnology Center A. This is quite new, as you can see, and nice building in which we have many modern classrooms, fully equipped, multimedially equipped. We have also nice library, where you can find nice space, nice atmosphere to study, and we have also big social zone, let's say like that, when you can spend time, rest a little, and spend time with your colleague and other students between resting between classes, between your activities, students' activity. We have also in this building whole level dedicated to experimental laboratories, science laboratories, where you will perform your study, this practical part of your study. And what is as important as regards this program, Nanostructures and Computer Simulation in material science, we have also computer laboratory, which will be used during the program implementation. Okay, when we think about nanotechnology, nanoscience, nanomaterials, nanophysics, so we think about reduction of the substance size to the nanoscale, which lead to the changes of properties, and always often we obtain unique properties of this system, subsystem. Okay, and this stimulate development of new technologies and new materials. And for this reason, our program study give you possibility to learn about, to gain knowledge about the type of nanomaterials and their properties, nanomaterials synthesis technologies, about methods, techniques, and experimental setup which are used to characterize these nanosystems, and about present and future application of nanomaterials. And finally, as a final task of this program is gain skills and practice in designing new materials in the experimental sense, and also in a numerical sense. So to design and predict properties of new, completely new and not existing physically materials. Whole study program is divided into 6 modules. So we have core courses, experimental modules, computer simulation module, and specialist courses. And we have also ancillary courses, some additional courses, and module dedicated to project, group project, and this is the most important master thesis project. And when we look on this block diagram of this program, we see that we start, in fact, from core courses. So the first semester is quite whole dedicated to these courses. Then we, step by step, we develop your skill as regards laboratory work, scientific experiment, then numerical experiment. And as I said before, last semester is quite whole dedicated to master thesis project, so the final project you should perform. When we look deeply to core courses, so we see that they give you fundamental knowledge about nanotechnology, but also about other related field of study. So you see that between courses belonging to this module, we have physics of materials, quantum mechanics, thermodynamics, nanochemistry, theoretical principle of nanotechnology, surface science, and so on. Then after this module, we go to experimental module in which you gain practice and skills related to laboratory work. So you will have occasion to synthesize nanomaterials using different method like wet chemical method, high temperature annealing, physical vapor deposition, mechanochemical synthesis, and so on. And then these materials you can characterize using many modern experimental method and tools like electron microscopy, optical confocal microscopy, scanning probe microscopy, and many spectroscopy method, photoemission spectroscopy, UV-Vis, infrared, and so on. After experimental module, we go to computer simulation module, and this module is focused on computer simulations and computer-aided materials design and analysis. So starting from quantum particle approach by classical molecular dynamics simulations, you will perform also finite element calculations. And during this realization of this module, you will have also occasion to use computing resources of our academic computer center in Gdańsk, just mentioned. Okay, this center, this is the most important center not only in Poland but also in Europe, because we have the most powerful supercomputer called Triton in this computer center. Okay, if you need more information, you can follow, you can go to this link, task.gda.pl, and there you can find many other information about this supercomputer and this computer center. Okay, then specialist courses, so here you can broaden your expertise in other fields, not only technology, and ancillary courses, so we offer you as a part of this module Polish language courses to facilitate your life in Poland, and by this module you can improve your so-called soft skills in communication, written and oral presentation, working team, and so on. I think that these skills will be very useful for you in your future. And the last projects module related to the projects, I would like only to show you some examples of the project which have been realized by our student, which just already implemented this program, master study program. So, for example, detection of anti-inflammatory drugs on 3D printed electrodes, electronic nose based on surface plasmon resonance, computer simulation of structural, mechanical, and thermodynamic properties of pentagraphene nanotubes. This is structure which exists only numerically, theoretically, let's say like that. Then synthesis and characterization of bio-nanocomposites, tricalcium phosphate and carbon nanotubes, so material used in implantology. Investigation of nanocerium oxide with transition metal catalyst for methanation reaction, and so on, so on. I would like to stress that, as you can note it, this project concern the topical, let's say, topical problems, questions, and challenges of modern day. And some of them was awarded by Rector's Prize, Rector's Medal. To finish, so I would like also to underline that on the base of this master program, we can also create for you individual study plan to fit your study to your expectation and your interest. This is one path, okay? And other is related to joint interdisciplinary double degree master's programs, which are created on the base of this master program and is realized in cooperation with other universities from Europe. But about these double degree master's programs, for a moment, more details show you my colleague Justyna Szostak, so I leave only as information that you have these two paths. Okay. And ending, please remember, we offer you, I think, modern master program in nanotechnology, and remember that online admission starts in May, so really soon, and you should use this link, this web page, rekrutacja.pg.edu.pl to be admitted to our program, our master program, and I hope see you soon in Gdańsk. So see you, and thank you very much for your attention.
Your presentation of our master studies in nanotechnology, which we offer to you at our Faculty of Applied Physics and Mathematics. And now we would like to listen to Justyna Szostak, who is our faculty coordinator of the international cooperation, and she will present you the double degree diplomas and the offer of international exchange programs at our faculty. Justyna, the floor is yours.
Thank you. Hello again. This time, as promised, I will tell you a bit more about international mobility at our faculty, so the Faculty of Applied Physics and Mathematics. Let me first introduce the team members of our International Relations Office. It's a faculty office that works in addition to the main International Relations Office of our university. So we launched the International Relations Office in 2018, and back then it was just me on board, and now, as you see, we have 5 people collaborating to improve your international experience as students of our university, of our faculty. So the first 3 people from the top, it's Marcin Styborski, who is the Erasmus Plus coordinator for the students of mathematics, both for the incoming and the outgoing students. Then you can see Marta Prześniak-Welens, who is responsible for the outgoing students studying technical physics, material science, and nanotechnology. In the left bottom corner, you have Natalia Wójcik, who is responsible for the incoming students of the same fields of study. And this smiling lady, it's Magdalena Top, and she's working in the dean's office. Without her, nothing happens here. So it's a very important person and a very kind one at the same time. So we are really lucky to have her on our board. And then you can see me. I'm also the Erasmus coordinator, but I'm mainly responsible for the double degree students and the mobility of our employees. And I'm also responsible for all the big issues, let's say. So whenever a problem hard to solve appears, then I'm the one who tries to find a solution to it, of course, in collaboration with the other members of the team. We have two different types of international mobility. We can talk about short-term mobility, and then we have different reasons for that kind of mobility. So we can use the mobility for studies, for traineeships, so the internships, and for research. And students making use of such kind of mobility are called the exchange students. So they, even though they go to a partner university, they never become students of that university. They remain our students, but they are taking some courses at the partner institution. The basic source of financing for that kind of mobility is the Erasmus Plus program, but this is not the only program that we can offer. So later on I will show you the other external mobility programs. And the second type of the mobility is the long-term mobility, and this is the mobility for studies. And then usually the result of such kind of mobility is the double degree, the double diploma. So then you enter a program that is organized in collaboration between 2 or more universities, and then you are awarded at least 2 diplomas after graduation. But I will show you more details in a minute. So how many programs, international programs, do we offer at the faculty? As you see, we have 6 double and dual degree international master's program. So right now we have such an offer just for the graduate students, but I hope that in future we will also have some programs also for bachelor students. Apart from that, we have 65 Erasmus Plus bilateral staff and student agreements, and these are the agreements that we made with 23 countries, so the universities from 23 countries all around the world. And of course the number of these agreements is increasing all of the time, so we are working hard to extend our offer for the Erasmus program. What is really important is that you are not limited just to those agreements that we have at the faculty. You can also make use of the agreements that were signed by other faculties, so the university agreement. And as you can see, we have over 720 international agreements, both for science and education. And within those, we have over 600 Erasmus Plus agreements and over 30 double degree programs. So what is the Erasmus Plus? In a nutshell, of course. So for what is very important, students of all cycles of education can make use of this kind of a program. So we have the possibility to travel as an undergraduate, graduate, and PhD students. When you begin the adventure with the Erasmus program at the undergraduate level, it is important that you have already finished the first year of education. When it comes to graduate and PhD students, this rule does not apply. What you should remember is that you can make use of this program at every cycle of studies, and your mobility can be as long as 12 months in total. So if you make use of this program, so you join the Erasmus program at every single level of education, then you can spend 3 years of your education in several partner institutions. You should also remember that the Erasmus program is also for graduates. So if you apply for the Erasmus traineeship, if you still have the status of the student and then your mobility takes place after your graduation, then it is still financed from the Erasmus Plus funds. The amount of the scholarship, the height of the scholarship, it depends on the country of your destination. So what you can count on is between 400 and 650 euro per month, depending on the country that you go to. We can provide additional grants for people with disabilities and for people in a difficult social, financial situation. The period of your mobility should be not shorter than 2 months, And as I mentioned, the longest trip is 12 months, and you should remember that you can divide your Erasmus Plus adventure into several parts. So for example, you can go for 1 semester to one university, and then to change the university to another one, and then for example to go for summer internship. You cannot stay longer than 12 months in total in those institutions. What is very nice is that you do not pay the tuition fees in partner institutions. So when you become our student and you take part in the Erasmus Plus Mobility, you will not pay any tuition fees in the partner institutions that we collaborate with. Where can you go? Basically, you can go everywhere, but the simplest in terms of the organization of your mobility is the trip to the Erasmus Plus program countries, which are the EU members, then the members of the EFTA and EEA organizations, also Federal Republic of Yugoslavia, Macedonia, and Turkey. And as I mentioned, it is possible to travel to other countries, but then it requires us to sign separate agreements and to apply for special funds. As I mentioned, Erasmus Plus is the main exchange program, but not the only one. So we are working really hard to find all the opportunities for you to be mobile, to be international. So we are trying to find all the external traineeship and scholarship programs, so those offered by other institutions than our university. And these programs are listed and described on our website, so you can visit the section students and then choose the external traineeship and scholarship programs to find more details about those programs. Right now we have several dozens of programs of different kinds, both for education and science. The second type of mobility, the long-term mobility, is, as I mentioned, the dual degree, double degree mobility. So first of all, you are not an exchange student when you apply to this program. So you are a full degree student, and those studies last 4 semesters. You can count on the long-term international mobility, because for our programs at our faculty, you have to spend at least 1 year in the partner institution. So you study for 2 years, 1 year is spent at our university, the other one is spent at the partner university. Your master's thesis is prepared under co-supervision of both universities. Very often these are interdisciplinary programs, so involving more than one field of study, and the fields of study that you can choose from is nanotechnology, mathematical engineering, and physics. And depending on the program that you choose, you are awarded 2 degrees out of those 3 fields of study. So 1 program, 2 diplomas. The list of those international joint programs and dual degree programs is available on our website. If you click on any of these sections, so like the intermaths, let's say, you will find all the details regarding the partners of that program, the list of courses, and all other requirements that you have to meet to be the member of such a program. Our main collaborators, main partner universities when it comes to double degree programs are the University of L'Aquila in Italy, the University of Camerino, and INSA Lyon in France. The internationalization is not only the mobility of students, so we can also think about the mobility of professors. And I'm not talking about our professors who visit other universities, but about professors from other universities visiting our faculty and running the classes, even whole courses for our students. And as an example, you can see the visiting professors from only several of them from this academic year, and this is Professor Cava from Princeton, Professor Weiwei Xie from Rutgers University, and we have Professor Zygmański from Harvard Medical School. But we had also visitors from Spain, France, that were running full courses, like 60-hour courses for our students of mathematics, physics, material science and nanotechnology. All the information about visiting professors you can find on our website. We are also announcing our guests on our Facebook and other social media. Thank you. If you have any questions, let me know.
Thank you, Justyna, for the presentation of our double-degree diplomas and international exchange programs. Now to finalize our English language block of our virtual open day, we would like to introduce Professor Aleksandra Mielewczyk-Gryń, who will make a lecture about the nanoscience of the future. Aleksandra, the floor is yours.
Thank you, Beata, for introduction. So today, as a conclusion of this very interesting talks about our faculty and our programs, including international programs, I would like you to know why you should study nanotechnology and why nanotechnology is such an interesting topic. So I had some thoughts about how to call this lecture, so I ended up with this one, so nano/science of the future. Yes, it joins two things, nanoscience, so science which is focused on nanotechnology and nanoscale materials, and the future. And this is one of the reasons I really love nanotechnology and why I'm interested in this topic, is that nanotechnology is an essence of a future, and everything that you're watching on TV or in theaters when you watch sci-fi movies is basically possible as an ending point of different nanotechnology methods. So what is nanotechnology and the word? So the word is not so new. Maybe a little bit newer for me from my perspective because I'm older, but still the first mention of the nanotechnology, hyphenated, is from 70s when Professor Taniguchi first at the conference used this term to describe things and technologies which would be possible in the future by using materials which are accessible in nanoscale. Then a little bit later, because in 1986, Professor Eric Drexler wrote a book that revolutionized what we think and how we think about materials and how we feel about nanotechnology. And he was the first to use this term unhyphenated, and he was the one to introduce nanotechnology as a term to our vocabulary. Professor Drexler wrote a book which was called Engines of Creation, and he was describing the theoretical model in which we will have the self-assembling assemblers, which can self-replicate and build another building blocks. So it was a book about the future, and this is how the nanotechnology became a new field, a new future idea for how to work with materials and how these materials can be developed to better world, to better humankind. So what nano means? Because it's nanoscience, nanotechnology, why nano? So nano is a prefix that is used to describe everything that is in the order of magnitude 10 to minus 9. So something very small. And nano, the word, comes from the word meaning dwarf. So let's say that nanotechnology is a science of the dwarfs, but it's not so much. When you look how many times then the word nanotechnology appeared in the history, we can see how this field developed. So this dwarf science, nanoscience, is developing from 80s when it was first mentioned, say end of mid-70s and 80s, and now it become super popular word. The more popular it is, the more interesting it is for us. Why? Because the more people are interested in nanotechnology and making nanotechnology possible to make nanomaterials, the more possibilities you as a student can have to learn how to do them, how to apply them, and how to work with them. So when you look at the time scale and how the word nanotechnology appeared in the literature, and this is based on Google Books, we can see that it skyrocketed sometimes in beginning of 21st century for sure, and it's still rising. The more nanotechnology is appearing in our day-to-day life, and more nanotechnologies appear in the science. So what is nano, and how this scale of sizes can be compared to different things? So here we have the scales of the basic things that you can know, the things that are described in physics class and chemistry class. So we have atom, which is 0.1 nanometer, so it's smaller. Then we have the standard, we will talk about this buckyballs and fluorines, so the ball made from carbon atoms, which will be in the order of magnitude of 1 nanometer. Then we have DNA, which is bigger, so it's 2 nanometers. And then we have viruses, bacteria, cells, hair, and at the end we have some kind of pollen. So everything from the very small things, from the atom, add to the which something that is quite small, so the pollen, but still can see how the scale of sizes is full of different things. And by using nanotechnology, we can make this happen, that we are using all the scales coming from the nanofilarians, ending to the pollen, and to make new materials, the better materials, and more functional materials. And this is why nanotechnology is. So if you ever wonder what nanoscience is and why we are so keen on doing nanotechnology, is that we can make multiple material by different multiple methods, and then we can utilize multiple techniques. So if you look at the time scale, I'm talking about size, and I can talk about time because it's very transcendental. So the nanoscience is a science of the future, and everything started in the 50s with Professor Feynman gave his famous talk, which is called "There is plenty room at the bottom." And this is the basics of the nanotechnology. Plenty room at the bottom, meaning that we can do so much by manipulating the very small structures. Then, like we said, the first terms by Nomoguchi and Drexler reform as being nanotechnology. Then in beginning of 80s, STM, so scanning tunneling microscope, has been developed to manipulate atoms. Then in 1990, IBM for the first time manipulated atoms, and of course what they done, they made their logo out of the single atoms. But it's not of the pride, it just show how this can be possible, so we can manipulate the atoms and make the logo and make a picture, and while we make a picture, we can then make transistor from the atoms. So this is nanotechnology, the science of the people who feel in a different way. Then we have fullerenes, so I could say buckyballs, so the structures made solely out of the carbon in the nanoscale. When we look at the history of nanotechnology, it's completely linked with the things that are based on the techniques that we can use. When you look at the techniques of nanotechnology, they will be linked both to the synthesis of the different nanostructures, and you will be doing that while being as students of nanotechnology, and also the characterization techniques. So what we do while doing nanotechnology, we do both. We synthesize materials and we analyze the properties. And then when we analyze the properties, we can modify them in the way that will fit the particular requirements of the, let's say, fuel cell, solar cell, or the nuclear power plant. So we can use this nanotechnology, so use these dwarfs to build a new future, a new materials, new applications. So, and also when you look at the people who are doing nanotechnology, we are not so down to earth all the time. So we think in the broad perspective. And this is why I wanted to show you this picture. So this is not nanotechnology, it's big technology. This is a building. So, and this is the creator of this building, Mr. Buckminster Fuller, who was developing this enormous buckyballs, how they are called, so enormous building, which are in the form of spheres. And like you can see of this that there is Fuller and Buckminster. So I use two similar words, Fulleren and buckyball. So people scientists who invented or discovered fullerenes, so a nanostructure that are made solely out of the carbon atoms, they were so aware of how the world looks like that they saw the resemblance between this nanoscale and the macro scale of the Buckminster Fuller's buildings. So this is why they called these structures made of the carbon fullerenes or buckyballs. So every scientist who is doing the nanotechnology, we know what fullerene is. So this is the first structure that you will learn as an example of these marvelous properties that nanostructural materials can do. Then another level was, okay, so we have a buckyball, we have a ball made of a carbon, let's make a tube of it. And another structure that is super important from the nanotechnology point of view and then applications of nanostructure is the nanotube. So imagine that you are able to make the tube solely out of the carbon atoms which are aligned in a sheet which is folded. And this is the nanotube. So when you look at the things that you as a nanotechnologist can do, you can see like enormous number of applications that you can apply your materials to. But also you can go back and see like the world as it is. So you can just you can join this journey with us. So you can see how the world is developed on your materials and how the world influences how you see your materials. Then the material that is super important from the point of view application, and now the people are also talking about it, is graphene. So we had the buckyball, which is here. We have a fullerene right hand side corner. And then we have a graphite, which is on the left side corner. So the one is nanoscale, like we said, 1 nanometer, 60 atoms of carbon for C60 fullerene. And then on the left hand side, you have a piece of carbon. Some kind of, so what is graphene? Graphene is a sheet made of the carbon. So you have a two-dimensional material, which you have this, you can see honeycomb structure, in which in of these points of the honeycomb, there is a carbon atom. So you have a sheet of the carbon atoms. And this material is important from the point of view of applications, and to make this material wasn't so obvious, because even in 90s people said that it's impossible. And this is nanotechnology and the essence of nanotechnology. It's making things which are impossible possible. And the people who really made a lot of work on the carbons was on the carbon 2D materials, so graphene, was Andra Game and Konstantin Novoselov, which were working in Manchester University in UK. And they got a Nobel Prize in 2010 for groundbreaking experiments regarding the two-dimensional material graphene. And their work was marvelous. They make a simple method by which they were able to synthesize, to produce graphene layers. And what they used the Scotch tape. They took the brick of the coal and of the graphite, maybe not the brick of the coal, but the graphite, and they were exfoliating the thin flakes of graphite, and then by another exfoliation they were able to prepare the graphene sheet. Who would have thought about doing that? So this shows how very versatile people are who are working with nanotechnology, how they thinking out of the blue is important. And Andra Game is one of the best examples of it. So Andra Game was one of the people who are awarded by Ig Nobel, which is, I don't know why, but it's sometimes called a anti-Nobel. It shouldn't be called like that, because Ig Nobel is a prize which is given to scientists who are doing stuff that is not standard. People who are trying to swim in a swimming pool full of the jello, or people who are wondering why the wombats' feces are cubes. So there are multiple things that Ig Nobel is awarded. And Andra Game was one of the one that got it. he got it from levitating a frog in a magnetic coil. So if Andra Game weren't such a person who would use magnetic coil to levitate a frog, he wouldn't be a person also to produce a graphene out of the Scotch tape. So one thing that is very important, and I think that is the most important thing you should think, if you think about studying nanotechnology, that this is the science and this is a field for people who think out of the box and have different ideas, and they are free-minded and want to change the world. Thank you.
Very interesting lecture. I hope that you have fallen in love in nanotechnology after such presentation. So this is the end of our English language part of the virtual open days at the Faculty of Applied Physics and Mathematics. This streaming will be retransmitted at 6:30. So if you didn't manage to attend our presentation from the beginning, please find the retransmission at the YouTube channel. Thank you.